Okay, so we continue our discussion in complex numbers. So, geometrical representation. So, a complex number x plus yi can be represented either as point xy or as position vector in the xy plane. So, si x-axis natin is called the real axis and y-axis is called the imaginary axis. So for example, we have the complex number z is equal to 3 plus 4i. If you're going to plot it in the Cartesian coordinate uh, plane, okay, sorry, bangki-bangking. So this will be equal to 1, 2, 3. Wait, this is the x-axis, which is real part. And then this is y, which is the imaginary part. Okay. So ito ngayon yung real natin. So this will be at the x-axis and this is our imaginary, which will be at the y-axis. So 3 and then 4 dito sa y natin. Okay, so that is 4. So yung complex number natin is nandito. So z is equal to 3 plus 4i. So this is the geometrical representation of a complex number. And this diagram, this one, is called the Argond diagram. Okay, so this geometrical representation of a complex number is called the Argond diagram. So we proceed to the modulus of a complex number. So let z be equal to x plus yi. The modulus of z is denoted by absolute value of z, and z bar is equal to the square root of x squared plus y squared. So that is the modulus. Modulus of a complex number is the non-negative square root of x squared plus y squared, or it is the absolute value of the complex number or of z. So properties of modulus. So the modulus of z squared is equal to z times z bar. The modulus of z bar is equal to the modulus of z, or the absolute value of z. And then the modulus of z sub 1 times z sub 2 is equal to the modulus of z sub 1 multiplied by the modulus of z sub 2. And then the modulus of z sub 1 over z sub 2 is equal to the modulus of z sub 1 over the modulus of z sub 2, provided that z sub 2 is equal to 0. Kasi kapag naging 0 na si z sub 2, that will become indefinite. Okay? So, let's try examples. We have example number 1. Consider z sub 1 is equal to 3 plus 5i, and then z sub 2 is equal to 2 plus 2i. Find the modulus of z sub 1 squared. So, from the properties, the modulus of z squared is equal to z times z bar. So, ito magiging z sub 1 times z sub 1 bar. Okay? So, how do we do that? Yung z sub 1 natin is equal to 3 plus 5i. Now, z sub 1 bar is the complex conjugate of z sub 1. So, magiging 3 minus 5i. And we proceed to simplification through FOIL method. So, this will be equal to 9 minus 15i plus 15i, and then positive 5 times negative 5, that is negative 25i squared. And I squared is equal to negative 1. So negative 25 times negative 1, that is positive 25 plus 9. Okay, so this will cancel. So the modulus of z sub 1 squared is equal to 9 plus 25, that is 34. Okay, so this is the final answer for letter A in example number 1. Now let's have still in example number 1, letter B naman. So same sa ginawa natin sa letter A, magiging z sub 2 times the complex conjugate of z sub 2. So this will be equal to 2 plus 2i times 2 minus 2i. And then FOIL method, this will be 4 minus 4i plus 4i minus 4i squared. I squared is equal to negative 1. This will cancel. So 4 plus 4. 4 plus 4. So this will be equal to 8. So this is example letter B. Letter B in example number 1. Okay. So let's try letter C is still in example number 1. Find the modulus of z sub 1. So yung modulus of z sub 1 natin dun sa definition kanina, the modulus of z is equal to the square root of x squared plus y squared. Okay? So here, z sub 1 natin is 3 plus 5i. So this is our x and this is our y. So x is equal to 3 and then y is equal to 5. So z sub 1, the modulus of z sub 1 is equal to the square root of x squared, which is 3 squared, plus y, that is 5 squared. So this will be equal to square root of 9 plus 25. So the modulus of z sub 1 is equal to square root of 34. Okay? So that is example number 1 in the properties of modulus of complex number.